Hello, Math 1435. This is Pre-Calculus 2, Trigonometry. It's Professor Wenson here. And this video is going to be on section 7.1, and specifically on section 7.1, part 1, the part 1 assignment from your KnewtonAlta I'm going to be going over, on angles as rotations and radian measures. Alright, so here I am. This is Math, your Math 1435 Canvas page. Now I'm in the teacher mode right now, but you'll see the same modules. This isn't published yet, but when you get on this later, you should see this week 1, and you'll see in every week there will be pages for for the section you're going to be section or sections of the material you're going to be covering that week. So open it up. So this is section 7.1 on angles. In each page on every section, you're going to see the objectives. What you're going to be, what you're going to be taught, or what you're going to be expected to be able to do by the end of the section. These are also the objectives. The objectives you're going to see in the KnewtonAlta homework as well, which is what I'll get to later in the video. Beneath the objectives, you'll have in the Canvas page, you can scroll through the textbook. This is from OpenStax, and read section 7.1 here, or if you don't like that, if you want to have a separate tab open, you can click on the link section 7.1 and a new window should open up at openstax.org. Eventually, at section 7.1. And I would highly recommend you read, before you try the homework, of course. Read and practice on your own, take notes. And it's just like any other textbook. You have read, pay attention to the bold words, definitions, diagrams, figures. And just read it as you would any other textbook, and take notes on it. And there are definitions in boxes here, some examples. Now if I were you, I would try to do the example first, right? See if you can do it before you click on show solution, right? Just to see if you know what's going on. And and then you got these try-its as well, where you can do that on your own as well, practice. So you got a bunch of headings, like I said, bold words, lots of stuff, lots of pictures. Okay, and you can again read through this on your own. I'm not going to read this to you. Plenty of some examples to try-its, lots of things. Okay, so like I said, I leave that to you. All right, then beneath now don't scroll here, because if you scroll in the middle, you'll actually be scrolling through the book page. All right, so make sure your cursor is on the outside of that and scroll, and then below the book page, below the section 7.1 OpenStax book page, you have some videos. All right, and these are some videos pulled from other sources, whether it be YouTube or some outside websites. Videos that I didn't make, all right, on the different objectives. And you can watch these if you wish as well before you start with the homework. Do the reading, take some notes, practice some examples, watch videos, take notes on those as well. Right? Maybe I would recommend you do that kind of stuff before as preparation to do the homework. So you got draw angles in standard position. You got some videos related to that objective. Another bullet point here, convert between degrees and radians. Another couple videos there, and so on. You'll see an objective with some videos related to that objective. Okay. Then after that, for Math 1435, Math 1465 as well. Professor Dave Friday, who's another professor at Macomb, has put together some playlists for the different sections, and you can play them here. Just hit play, and if you know this video is an introduction, and if you'd like to see what other videos he has, you click on the upper right corner, you play other videos related to section 7.1 stuff. Okay, and this will be at the bottom of every section. You can see Professor Friday's playlist of videos as well. All right, now the important stuff. All right? I mean, of course, the reading and watching videos and taking notes, practicing exercises on your own, examples on your own beforehand is important, of course. But the stuff that's going to actually be factoring into your grade are the KnewtonAlta homeworks. So you have two of them for this section, Section 7.1 Part 1, Section 7.1 Part 2. Right, so I'm going to click on, this video is specifically on Section 7.1 Part 1. And I'm having here load it in a new window. Okay, now I'm on the Newton Teach area. I'm seeing this is the teacher view. I'm going to show you what this looks like as a student. Right, so I'm going to go preview as a student. And you see Newton Learn as opposed to Newton Teach. Alright, now if this is your first time using Newton, let me just show you to explain to you what you'll be seeing. You'll see the title of the homework, Section 7.1 Part 1. You won't see the word preview. Right? I'm seeing the word preview. You'll see the title. Upper right corner, the mastery bar, which takes you through, shows you how far along you've gotten in the assignment. And as it relates to grades, once you've filled this to 100%, then you will see that 100%, that 100, show up in the Canvas gradebook. But if it's not filled, right, if you only get to 70%, you won't see that grade until the day that it's due. And remember, I had this set up so that everything is due. All the assignments are due on Sunday, May 9th at 11:59 p.m. So if you only do 70% of it, 75%, and you're happy with that, which I wouldn't be, but and you want to leave it at 70%, you won't see that 70 show up in your gradebook until May 9th, until the time it's due. Okay? The only time you're going to actually see a score show up is if you actually complete it fully, 100%. Yeah. Okay, so I hope that's clear. Right? You get 100, you'll see it right away. You don't get 100, you won't see it until May 9th. Then you have a question below that, and above that the objective that this question is related to. And you see current objective, understand when two angles are coterminal. And I'll go into what that means. I'll show you some stuff on some paper, teach you some things hopefully. And if you'd like to see what, and you can also see the progress you're making. There's a little circle with a star here. You can see the progress you're making on that particular objective. Then if you click on the down arrow here, you can also see the progress breakdown, which is a list of all the objectives. Right? There are 3 of them in this particular assignment, and your progress on each of those objectives. Right? Now I want to point this out right now. The questions I see, there are a lot of questions in KnewtonAlta. So the questions I see in this video, the numbers I see, the words I see, are not exactly the ones you're going to see. Every student's going to have a different experience. But the material is the same. How you do the problems is the same. All right, so if you watch this video here and follow me along, you'll get a guide. You'll see how to work these problems. Okay, again, they might not be exactly what you're seeing, but they'll be similar. And hopefully I give you enough information to where you can do them also. Now my suggestion to you, if you've done the reading and watch videos and you feel comfortable with the material, you can, I'd say, start answering questions right away. Go ahead. If not, if you don't feel comfortable with the material, I would recommend that the first time you come across a new objective, like this one here, see no progress. This is a new objective. On the bottom of the problem, you'll see a more instruction button. I would click on this more instruction button if I see a new objective, or if I'm just struggling on a problem and I don't want to guess, right? Don't guess a lot, because if you get the more you get things incorrect, the more problems will be thrown at you and the longer the assignment will take. I would say if you're struggling to understand a problem, click on more instruction and read through the instruction and work on the questions in more instruction first and get through the assignment that way. And you can actually do this for every single problem. Now, I know you're probably thinking, hey, do I have this? No, you don't. Right? The instructor cheat button, you do not have that. Right? You are not an instructor of the course. All right, so this is understand when two angles are coterminal. I'm going to click on more instruction. View instruction. And when you do this, you'll see some instruction come up. Now, I'm not going to watch a video within a video. All right, I'm not watching this video with you. There's a video, sometimes there's videos, sometimes there's just words taken from, and most of the material that's taken, if it's written in words, is taken from the OpenStax book, which I've shown you here, right, in that page. So there's a video, and that's it. Now let me explain. I'm going to go to a piece of paper and talk about coterminal angles, and we'll get to the question here. After you hit continue, I read through the instruction, or I watched the video they provided for me, and now I'm going to ask, I'm going to hit continue, and then a question will pop up where I can still go back to the instruction if I need help. All right. But I'm going to go, they're saying our angles of 132 degrees, right, this little degree symbol there, and negative 588 degrees coterminal angles. All right, so I'm going to go to a piece of paper and explain to you, how to draw angles in what's called standard position on the XY coordinate plane. And then what does it mean for two angles to be coterminal? Okay, so over on my paper, so angles in standard position. So when you draw an angle in standard position, what that means is you're going to have the XY coordinate plane, right? You probably remember this from algebra or pre-calc 1. Right? You have the XY plane, x-axis, y-axis. And when you draw an angle in standard position, the vertex of that angle is at the origin. Right? The vertex of the angle is at the origin. And every angle has two sides. An initial side, where you start from, and a terminal side where you end the angle. And an angle is just a measure of rotation, just a measure of turning. Now, when you're drawing an angle in standard position, you're always going to, on the XY plane here, the initial side where you start from will always be the positive x-axis, right? The right side of the x-axis, the side of the x-axis to the right of the origin. This will be the initial side. Right? And then you do a certain amount of turning. All right? Now the turning from here could either be counterclockwise, right, going to the left, well, up and left, counterclockwise, or the turning could be clockwise. And there's a big difference. All right, I start here on the positive x-axis. I do some amount of turning. Say I turn that much. and then I end at what's called the terminal side, right? So always emanating from the vertex here, from the origin. So here is an angle, right? This is an angle, and again, it's an amount of turning or some amount of rotation. And this side that I ended the turning at is called, the terminal side or the ending side. You have beginning, initial, and ending terminal. Okay, that's how we draw angles in standard position. Now, the thing I mentioned about the turning, if you draw a counterclockwise turn, right, going this way, counterclockwise turning, those angles are going to be said to have a positive measure. These are for positive angles, positive angle measures. The other way around, if I turn clockwise, right, this way. So if instead of going this way, I drew an angle, if I started from the initial side here, the positive x-axis, and went the other way, that would be for an angle with a negative angle measure. So clockwise, a clockwise turn is for negative angle measures. Okay, so now how are angles measured? Well, once around, right, one full rotation, if I rotate the entire way around, so I'm just going to pull this up again and draw another coordinate plane. The vertex, the initial side. If I go one full turn, from I start at the positive x-axis and I end at the positive x-axis, that is a 360 degree angle, right? And the little degree mark there. Okay, so 360 degrees. If I go just to the axes, if I go to the positive, if I start here and go to the positive y-axis, that's just 90 degrees. All right, that's just 1/4 of the way around. If I go, that's the same color. And if I do starting from the positive x-axis when I'm drawing in standard position, if I do that amount of turning, just turn until I get to the negative x-axis, that's 180 degree turn. Right? If I turn this much, right, 3/4 of a full turn, that's 270 degrees, right? And then again, all the way around to the positive x-axis again is 360 degrees. And then if I reversed these, if I went clockwise, those would be negative angle measures. All right, so I'll just draw one of those. So here, if I started, again, you're always starting at the positive x-axis. If I start here and do a turn clockwise, if I go this way, clockwise, that's 1/4 of a full turn, right? So a full turn would be negative 360 degrees. So this amount of turning here is negative 90 degrees. Okay, so pay attention to the orientation. Am I turning clockwise or counterclockwise? Now, what it means for two angles to be coterminal, right? The title of this objective, right? We're talking about angles that are coterminal. Angles are coterminal if they have the same terminal side. Remember, there was an initial side and a terminal side to any angle. So these are angles with the same terminal side. All right, so again, a XY axis, I'll be drawing a lot of these throughout the semester. So if I draw, say, this angle here, all right, let's say there's again the initial side on the positive x-axis, and say I go counterclockwise, there's the terminal side, right? The terminal side of that angle, and usually angles are going to be labeled with either a capital English letter or a Greek letter. All right, you might see angles very often labeled as, say, angle alpha. Right, this is alpha, or beta, or gamma, or theta, like a little O with a slash in it, and so on. I mean, there are 24 Greek letters. So very often an angle is going to be, you're going to see in a lot of texts, angles labeled with Greek letters or capital letters, like just a capital A or something. All right, so there's angle alpha, this amount of turning, this amount of rotation. And then they ask, and I say, how do I get an angle that's coterminal to angle alpha, with angle alpha? Again, any angle drawn in standard position that has the same terminal side, ends in the same place. So if I start here, again, start here, and I turn this way and go all the way around, then go some more. You can go more than 360 degrees. You can measure more than 360 degrees. So this angle I just drew, this amount of turning, this amount of rotation, ends at the same place. And let's say this angle is called beta. And beta represents this amount of turning from the positive x-axis. We would say that alpha and beta are coterminal. And can you see how, like, all I had to do was take alpha and go once around to get beta, right? You could also have gone clockwise once around. Well, remember, going one full turn, once fully around, to get back to the same place, that's 360 degrees. So to get coterminal angles, you can add 360 degrees, subtract 360 degrees, or any multiple, any integer multiple of 360 degrees, right? So that's a big point here. So coterminal angles differ by an integer multiple of 360 degrees. Okay. All right, so let's go back to the assignment. Right, the question we were given are the angles of 132 degrees and negative 588 degrees coterminal angles. Okay. Well, let's see. I'll draw those back on the piece of paper. So 132 and negative 588. All right. So the first angle, let's say it's alpha. Say alpha is 132 degree angle. So I'm going to draw that in standard position. So again, the initial side here, this is a positive angle. All right, a positive angle. That means I go counterclockwise. All right. So here's 90 degrees. All right. That's 90 degrees to the positive y-axis. And then I can't, going to the negative x-axis is 180. That's too big. So that's 90 degrees, and then another 42 degrees, right? So let's say 45 degrees is about halfway. So let's say there's 42 there. So here's alpha. All right, there's a 132 degree angle measure. All right. And the other angle that was mentioned, again I'll call it beta, was negative 588 degrees. All right. So again, starting from the same positive x-axis here, starting from the same initial side, sweeping out negative 588. All right, so that's going clockwise if it's negative. So negative 90, negative 180, negative 270, right? Negative 360. Then more, even more, another negative 90, it'll be negative 450. Negative 540. Almost there. Now, if I go it again, it's negative 630. That's too much, right? We're only going to negative 588. So right now I'm at negative 540. I need negative 588, so that's another 48. Well, I said earlier that this little bit was 42 degrees, right? Because that's 90 and 42 make 132. That means that this little bit here must be 48, right? Because these two need to add up to 90 degrees. Every quadrant has to have a 90 degree total, right? And that's exactly what I need, right? So I'm at negative 540 plus another 48. I am at the same terminal side. You know, that takes me to that same terminal side. Here's beta. Negative, right? Starting here, going clockwise, negative 588. They do have the same ending spot, right? The same terminal side. So these are coterminal. Now, a much quicker way to do that is just subtract them and see if you get a multiple of 360 degrees. So what's 132 minus, negative 588? Right, just subtract them. See if their difference, as I mentioned on this page, right, they differ by a multiple of 360. So subtracting a negative is adding. So that's 132 plus 588. That would be 720 degrees. Positive 720 degrees, which is 2, an integer, times 360 degrees. So they differ by a multiple of 360. Meaning they're coterminal. All right. Right? Because all I had to do was take this angle. If I took alpha and then just subtracted 360 twice, right? They differ by 2 360s. I'd end at the same spot, and I'd get angle beta measured out. Right? So back to the homework here. Now I know it's just again, don't guess. I know you got a 50-50 shot, but the more you guess, the more problems you're going to get and the longer the assignment will take. So are they coterminal? As we saw in my picture, yes they are. Then submit, and it'll give you some words of encouragement like, yeah, that's right, keep it up, or keep going. Even if you get it wrong, it's going to give you some encouragement as well, like, hey, don't worry about it, we all make mistakes, that's how we learn, and stuff like that. And then, answer explanation. There's a video there to help explain what was going on. Right? Okay, continue, and here's another question. All right, determine an angle between 0 degrees and 360 degrees that is coterminal to an angle with a measure of 1,524 degrees. And then pay attention to how they want you to enter answers. To enter your answer below without a degree symbol. Right? Just enter the number, so don't try to enter the degree symbol. All right, so 1,524 degrees, and we want an angle that's only between 0 degrees and 360 degrees that has the same terminal side. All right, so I'm going to go back to the paper here. All right, and 1,524 degrees. Now, one way to do this is just, keep subtracting 360 degrees until you get an angle between 0 and 360. Now, I'm not going to do that by hand here, but bring up my calculator. So here's 1524, and then I just keep subtracting, 360. That's too big, that's not between 0. A 1,164 degree angle would be coterminal with a 1,524 degree angle. Subtract 360 again. That's an 804 degree angle would be coterminal with a 1164 degree angle and a 1524 degree angle. Take away 360 again. A 444 degree angle would be coterminal with all these angles, have the same terminal side. And that's too big. It's not between 0 and 360. So it looks like one more time. All right, minus 360 again. An 84 degree angle is coterminal with an 84 degree angle. All right, and let me show you. All right, draw 84 degrees. So again, starting from the positive x-axis, always, for these standard position angles. Positive 84 degrees is just go counterclockwise, and then that's a little less than 90. So I'm ending right before the end of the first quadrant here. So there's 84 degrees that I just drew, right, counterclockwise. And what did we do on the calculator, right? I subtracted 360 4 times, I believe, right? 1, 2, 3, 4. Yeah, so if I add 4 times 360, right, if I just take this and add 4 times 360, I'm getting that 1524. Well, doing that in my picture is doing this. Taking the 84 degree angle, and I go 84 degrees, right? There's 84 degrees, and then I just go around 4 times. 1, 2, 3, 4. Right? There is a it looks silly, but this big spiral thing that, again, starting here, ending here, that is a 1524 degree angle that I just drew. It's a 1524 degrees of turning, and it ends at the same spot as an 84 degree angle. Right. Okay, so back here now I said enter without a degree symbol. Even though I know you see the degree symbol here, you might be tempted to put it, but just be careful. Read the instructions. So just 84 is all that's being asked for there, right? And submit. And great, and then again, answer explanation comes up, another video. Cool. All right. Now, after you've done a couple, it looks like it's got one more for me with the instruction here. Which of the angles given below are coterminal to an angle with a measure of 68 degrees? Select all correct answers. So this might have more than one, this kind of a problem. All right. So again, just is the difference between them a measure of a multiple of 360? All right. So just subtract them. What's 68 minus negative 292 or plus 292? All right. Well, that would be 360. And if you don't believe it, right, just 68 minus negative 292. All right, 360. Okay, or if you'd like, you can do 68 and then just keep subtracting 360 and adding 360 to get a list of coterminal angles to a 68 degree angle. All right, how about 68 degrees minus negative 112? That would be 180. 180 is not a multiple of 360, so not negative 112 degrees. 68 degrees minus negative 68 degrees would be plus 68. That'd be 136. 136 is not a multiple of 360. 68 degrees minus 248. These are now that these are not a multiple of 360 apart. Right? They're 180 apart again. Right? They have a difference of 180 degrees. 428 minus 68 would be 360. 360. All right, 68 plus 360 would be 428. And then 608 minus 68. What's that difference? Be 540. But 540 is not a multiple of 360. So just these two are the angles coterminal with a 68-degree angle, right? They have to have their difference, the difference between them has to be a multiple of 360. I hit continue. We're back to coterminal angles. Continue again.
Welcome to an example of determining a positive and negative coterminal angle.
Okay, and now we're with another question. All right. Now we're seeing some different stuff, right? Now I want to get into talking about radian measure. Right? We've seen angle measures in degrees so far, right? One turn around, one full turn was 360 degrees. You know, which of the angles below are coterminal to an angle with a measure of, now you see this, see there's no degree symbol here? It says -4 times pi. That's the number pi. You might remember pi from a geometry class a long time ago. That's about 3.1415, so on. Right? 3.14. 4 pi divided by 5. And it's negative. What is this? All right, so I want to get into that and talk to you about radian measure. All right, so back to my paper. You know, what is radian measure? Let me get rid of the calculator. So we've seen degrees, right? 360 degrees is one full turn. Well, let's take a full turn, right, which makes a circle. Let's say this is a full turn, right, horizontal and all that. I have a circle, right? One full turn makes a circle. Okay. A circle has a radius, right, which I'll call r, right, lowercase r, radius r. An angle that measures 1 radian as opposed to 1 degree, right? An angle that measures 1 radian. If I were to take the radius of the circle, and then, you know, from this point on the circle here at the end of the radius, I do some turning, and I turn so much. I walk along this circle and turn until I travel the same length as the radius, right, and end up here. So, you know, so this distance I've traveled right here, so going this here, that's also the radius. It has the same length, radius r. So this is a distance of r. Then I travel along the circle a distance of r. And again, the distance back to the center of the circle is also a distance of r. So I get this little like piece of pie, a piece of the circle where you have radius, and then, you know, the length of the curve on the circle is also the same as the length of the radius, and then another radius, another distance, you know, straight line to the center. If you do this, the amount of turning that you've done, this amount of turning that I did, right, this angle, is called 1 radian. Right, let me put it out here. This angle here is 1 radian. Right. Okay. And then how many of these make up a full circle? How many of these radians make up a full term? Well, again, hopefully you recall that the circumference of a circle, right, this is again probably going back to some geometry class you had a while back, is 2 times pi radiuses. Or it's 2 pi r. So there's one radius, 2 radius, 2 radii, 3 radii, 4, 5, 6. All right, if I take this walk this radius distance all around the circle, and then a little bit more, right? Because remember, 2 pi is about 6.28. Remember, pi is about 3.14. So this here is about 0.28 radiuses. All right, so I got 6 radiuses and then about 0.28 radiuses to make one full turn. So remember, one full turn or one revolution, they'll call it. One full turn or one revolution is 2 pi radiuses, or the way they would say it in terms of angle measure. 2 pi radians. The amount you turned was 2 pi radians. Right? And recall that this is the same thing as 360 degrees. Right? So one full turn is 360 degrees if you're measuring in degrees, or one full turn is, one revolution is 2 pi of these radian measures. Right? And now noting these, we can see that an angle that measures 2 pi radians, right, is the same as an angle that measures 360 degrees. So here's a way to convert. And if you divide both sides by 2, you get the more common conversion between the two, between radian measure and degree measure. Pi radians is equal to, divide by 2 is 180 degrees. Okay, this is our conversion factor. All right. So some examples here. All right. Radians and degrees. So when I'm drawing an angle in standard position, all right. So remember, this is starting point always on the positive x-axis. Remember, this is 90 degrees right here. Remember, this is 90 degrees when I stop here, if I just do that little turn. Well, 90 degrees, remember, that's a quarter of 360. Remember, I said on a previous page, a full turn is 2 pi. A quarter of 2 pi is pi divided by 2. Right? That's a quarter of 2 pi. Right? A quarter of that, 2 pi over 4, pi over 2 radians. Sometimes they'll abbreviate as rads. But notice there's no degree symbol. Usually they won't even write rads or radians at all. Another way to do that is to take 90 degrees and do a conversion. Right? Remember how you change from feet to inches? You can change from degrees to radians by using our little conversion factor down here. Right? If I want degrees to cancel, I put 180 degrees in the bottom, right? So that degrees will cancel, and then pi radians are just pi in the top. And then how many times does 90 go into 180? That's twice, right? And you end up with pi divided by 2. So 90 degrees, is the same as pi divided by 2. All right? And vice versa. So this is a pi divided by 2, or pi over 2 radian angle, also a 90 degree angle. Right? Here's another angle. Right? If I draw this and stop here, this is a 180 degree angle, right? But how many radians would it be? Well, we said already 180 degree angle is pi of these radian measures, right? Or pi radians. Okay, pi, again, you might see rads written, but usually nothing is written. All right, if there's nothing written for an angle measure, it's in radians. All right. So back to the problem at hand. All right, back to the problem. You see, they gave us an angle measure of negative 4 pi divided by 5. Now, if you'd like, you can change that to degrees. All right, let me show you what that would be in degree measure. All right, so, negative 4 pi over 5. Now, again, this is in radians. If there's nothing written, if you want to write rads, that's cool. But we use our conversion. Now this time I'm in radians, and I want to change to degrees. So instead of multiplying by pi over 180, I multiply it by the other way around. I do, times 180 degrees divided by pi radians, right? And again, the radians will go away, and I'm left with degrees, right? Now you say, how many times does 5 go into 180? right? That would be 36, right? So let's cancel that, 36. You still have degrees. And then what's 4 times 36? That'd be 120 plus 24, it's 144. And then you see the pi's canceling as well. Pi in the numerator, pi in the denominator. So this is negative, right? Negative. 4 times 36, negative 144 degrees. And if I were to draw this, right, in standard position, and I start from the positive x-axis, and I'm going as a negative angle measure, so I'm going to be going clockwise. There's negative 90, and I can't go to negative 180, that's too far. So negative 90, and then 54 more, right? Negative 54, I'm a little more than halfway. So here's negative 144 degrees. There's a picture of that angle, but that is also the same angle. Means exactly the same amount of turning as negative 4 pi over 5 radians. Right? They're both representing the same amount of turning. Okay? All right, now the question is, which of the angles are coterminal with this? Now remember, coterminal means that they have a difference that's a multiple of 360. Well, I told you earlier, 360 degrees is the same as this 2 pi radians, right? About 6.28 radians. So coterminal angles, right? When you're talking coterminal angles in radians now, coterminal angles have a difference that's an integer multiple, a multiple of 2 pi. So they're 2 pi apart, 4 pi apart, 6 pi apart, 8 pi, and so on. Right? Because those would be multiples of 360, right? Every 2 pi radians is the same as 360 degrees. Right? So coterminal angles have a difference of a multiple of 2 pi radians. I'll just say of 2 pi, okay? So again, all right, so now let's do the same thing as I did with this, the previous problem. We're going to take how far apart are these angles? What's the difference? And is that difference a multiple, an integer multiple of 2 pi? So what's negative 4 pi over 5 minus negative 14 pi over 5? That'd be plus 14 pi over 5. Now with fractions, remember fractions, you need the same denominator to add them, and you just keep that denominator the same and add the numerators. Hopefully you remember how to add fractions. So all of these have a denominator of 5, which is great. That'll make this pretty easy. So, what's negative 4 pi over 5 minus, what's the difference? But, negative 14 pi over 5? Well, that'd be negative 4 pi over 5 plus 14 pi over 5. That's 10 pi over 5. 10 pi over 5. And what does that reduce to? You know how to reduce fractions. 10 pi divided by 5 would be 2 pi. These two angles have a difference of a multiple of 2 pi. They have a difference of 2 pi exactly. All right, how about these two? When I subtract these, they have a difference of 2 pi over 5. 2 pi over 5 is not a whole number multiple of 2 pi. It's a fifth of 2 pi. 2 pi over 5 is not like 2 pi or 4 pi or 6 pi or 8 pi. So these angles would not end in the same place. These two have a difference also of 2 pi over 5. Right? They're only 2 pi over 5 apart, so they're not coterminal. These two angles have a difference of 6 pi over 5. They're not coterminal. 6 pi over 5 is not, a multiple of 2 pi, 2 pi, 4 pi, 6 pi, 8 pi, and so on. These two have a difference of 8 pi over 5. Again, not a multiple of 2 pi. And then these last two have a difference of 10 pi over 5, which is reduced to 2 pi. So it's only these first and last angles that are 10 pi over 5 or 2 pi apart, right? Which is like 360 degrees, right? Remember these 2 pi radians. These two angles are 360 degrees apart. These two angles are 360 degrees apart. And so those would be the only ones that would be coterminal with negative 4 pi over 5. Okay, so I've gotten through. Now, once you've gotten through an objective, and it'll throw you around. I mean, you won't always be working on one objective. It might throw you in one question, you'll be in one objective, and the next question you'll be in a different one. and you're not going to see problems in the same exact order that I am. You're not going to see the same numbers that I do, but you're working them the same way. Once you've completed an objective, though, a little way to go will come up, and then you just keep going. And you see a little star fill in there, right? All right. So next objective, convert between degree and radian measure of an angle. I've basically already told you how to do this, right? Now it's the first time I'm seeing this objective. I'll click on more instruction. But I've already told you how to do this. All right, and I showed you this same picture here. This is kind of like the picture I just drew, right, earlier, showing you how many radians. Right, there are 2 pi radians. Remember the circumference of a circle. There are 2 pi of these radian measures in a circle. And remember, 2 pi radian, an angle, 1 full turn, 1 revolution is 2 pi radians, or 360 degrees, whichever measure you're in. Meaning that, pi radians is the same as 180 degrees, or 1 radian, just 1 radian dividing by, if I divide 180 by pi, is about 57.3 degrees. Right. But we're going to use the pi and 180 a lot. Right. And so yeah, to convert, and I talked about 1 rotation, right, 360 degrees, 2 pi radians, cut that in half a rotation, half the way around a circle. Half a full turn is 180 degrees, pi radians. A quarter, I showed you, a quarter of a rotation is 90 degrees, or pi over 2 radians. These special angles measured in radians, I would get to memorizing these if I were you. Okay, especially for the first quadrant. And I'll write these out for you also, because these are going to show up quite a bit, right? So some special angles that'll show up quite often. So a 30-degree angle. Remember, I multiply this by, remember the conversion factor here, pi radians is 180 degrees. If I'm in degrees already, you multiply by pi over 180. A pi radian angle is the same as a 180 degree angle. It's just like multiplying by 1, right? Because this and this are the same measure. Degrees cancel. 30 goes into 180 6 times. So this is pi divided by 6 radians. All right, so a 30-degree angle is equal to a pi over 6 radian angle. All right. And I'll write that out to the conversion, right? To go from degrees to radians. To go from degrees to radians, multiply by pi divided by 180 degrees. That way degrees will cancel. To go from radians to degrees, multiply by just the reciprocal of that, 180 degrees divided by pi radians. That way radians will cancel and you'll be left with degrees. Okay. Alright, and then I do the same for a 45-degree angle. Now if you do that, a 45-degree angle, if I multiply this by pi divided by 180, 45 goes into 184 times. So this is pi over 4 radians. And a 60-degree angle, I multiply this by pi over 180. 60 goes into 183 times. This is a pi over 3 radian angle. I've already told you 90 degrees, right? 90 degrees is pi over 2 radians. So again, I would recommend memorizing at least these. Right? Basically any number that goes into 180 evenly. 30, 45, 60, 90. I mean, I know that 10 and 18 and 2 and stuff do also, but you're going to see that 30, 45, and 60-degree angles come up a lot in right triangles, certain special right triangles later in the course. So I would highly recommend memorizing these, that a 30-degree angle is the same as a pi over 6, pi divided by 6 radian angle. A 45-degree angle is a pi over 4 radian angle. A 60-degree angle is a pi over 3 radian angle. And a 90-degree angle is pi over 2. Please memorize these. And also how to convert, right? It's just pi over 180 or 180 degrees over pi, right, depending on what you're starting with. All right, so back to the assignment. And again, they go all the way around. Right? They go all the way around, and notice it's always either all these special angles are either going to are some multiple of 30 degrees or 45 degrees. Right? All right, and then an example. And all right, let's continue and get into a problem here. So what is the radian measure of 3/4 of a full rotation? All right, now remember, a full rotation, one revolution, a full rotation is 360 degrees. All right, and then they want the radian measure of 3/4 of a full rotation. So what's 3/4 a full rotation? That's 3/4 times 360 degrees. Where we already saw, this is 270 degrees, right? And you can, I had this up earlier too, like with the XY plane. There's a quarter, 2 quarters, 3 quarters. That's a 270 degree angle. I multiply this by pi divided by 180 degrees, and 90, right? 90 goes into this 3 times, right? So 90 goes into this 3 times, 90 goes into this twice, right? 90 goes into 180 degrees only twice. Degrees cancel, and I have 3 pi in the numerator, 2 in the denominator. 3 pi over 2 radians, right? Rads. So 3/4 of a full revolution or a full rotation is 3 times pi divided by 2 radians. So this selection here. Submit. Looks good. And they go through the whole thing and blah blah blah. Oh, they even put a full rotation here as 2 pi r. Do that as well. And then see how 3 pi over 2 radius is 3 pi over 2 radians. You can do it this way as well. All right, then we talk about converting, and I've already mentioned this to you. You're going to use pi and 180 a lot, right? Pi and 180. You can follow that along if you want. All right, I'm going to give you some examples. I'm just going to go right into a problem. So angle theta has a measure of negative 3 pi over 4 radians, right? Notice there's no degree symbol. That means it's in radians. What is the measure in degrees? Right. So negative 3 pi over 4. So back here, negative 3 pi over 4 is, I multiply. If I want to change this to degrees, I multiply by 180 degrees divided by pi. Right, that way the radians cancel and the pi's cancel as well. 4 goes into 180 45 times. And then 3 times 45 is 135. So, and it's negative. So negative 135 degrees. Another way you could have done that is you could have thought also, hey, I'm seeing pi over 4 here. And if you memorize those special ones from earlier, pi divided by 4 radians, that's 45 degrees, and then times negative 3 is negative 135. You could do that as well. All right. So negative 135, and notice I don't have to put the degrees in. I'm just putting the final result, negative 135. Submit. And it looks good. All right, and then you can use a proportion like they suppose, where your measure in degrees divided by 180 equals your measure in radians divided by pi, and then solve for the we knew the radian one. But it causes fractions over fractions. You're going to end up again multiplying by 180 over pi or pi over 180, depending on what you start with. All right, convert 126 degrees to radians. So let's do that. All right, so 126 degrees. To convert to radians, I multiply by pi divided by 180, right? Put degrees in the denominator, so degrees will cancel. All right, then we do a bunch of, now this is 126 pi, divided by 180 radians. I mean, that's totally fine. It's just not simplified, right? To simplify fractions. So I'm noticing that 9 goes into both of these evenly. All right. 18 actually goes into both of these evenly. But I'll start small, just say 2, right? 2 goes into this 63 times, 2 goes into this 90 times, and then, 9, I said it right, 9 goes into this 7 times, 9 goes into this 10 times, so I'm left with 7 pi in the numerator and 10 in the denominator, right? So 126 degrees of turning is the same as 7 pi divided by 10 radians of turning, right? They're both the same measure. And we got 7 pi over 10 down here. All right. Okay. It looks like I got. All right. All right. Then the last objective. Identify the measure of positive and negative angles in standard position and the quadrant of the terminal side. All right. Well, I've already shown you how to draw angles. I just haven't pointed out the quadrant numbers. All right. So again, I could do more instruction, right? If it's a new objective, I would recommend that, right? Clicking on more instruction. And then here's how to draw angles in standard position that I've already gone over, right? XY on the XY plane, the initial side, always on the positive x-axis and all that. How do you know if it's positives counterclockwise, negatives clockwise? They mention all that. Okay, and then the quadrant numbers. All right, you see these Roman numerals here. The quadrant numbers starting in the upper right corner, where the x values and y values are positive, are 1, and then they go counterclockwise, the way you would go for a positive angle. So 1 in the upper right hand corner, then quadrant 2, quadrant 3, quadrant 4. Okay. And then an angle, read definitions too, of course, right? And I would expect you to read all this. I'm kind of skimming through here. An angle is a quadrantal angle if its terminal side is on an axis. So that's not going to be in a quadrant. I know the name sounds like it would be in a quadrant, but a quadrantal angle is just some multiple of 90 degrees, right? So a 90-degree angle ends on the positive x-axis, 180, 270, 0, or 360, right? Any angle that ends on an axis is called a quadrantal angle, right? And then how to draw one, right? Okay, again, you can read through the examples on your own. I'm going to do all that. Let's get to the questions. All right, so which of the following images shows an angle of negative 70 degrees in standard position? Now this one's just multiple choice. Remember, negative means clockwise from the positive x-axis, so not this one. No, this one here, right? This one, no. This is from the negative x-axis. That's the wrong starting point. And same thing over here. So it's this one, right? We're starting from the positive x-axis and going clockwise, sweeping out this amount of turning, right? Negative 70 degrees. What quadrant does the angle 220 degrees drawn in standard position terminate in? All right. So I'll actually draw this one. So we're given 220 degrees. Here's the xy coordinate plane here. And remember, always starting from the positive x-axis. And then I'm doing positive 220 degrees. So I'm going counterclockwise. So this way, now this is positive 90. Too small. Positive 180. Still too small. If I go another to the next, the negative y-axis here, that's positive 270. That's too big. So here's positive 180. And then to get to 220, I need to go 40 more degrees, right? So 40 more degrees into this quadrant. And there you go. There's positive 220 degrees. Now again, they're asking what quadrant does that end in, terminate in? Now, this is upper right. It's called quadrant 1. And it goes counterclockwise. This is quadrant 2, quadrant 3, quadrant 4. And for some reason, they're always written in Roman numerals, right? So it ends in quadrant 3, terminates in quadrant 3. Right. Wonderful. A little drawing there. Okay, what quadrant would the angle negative, be careful, right? Pay attention to positive versus negative. Negative 340 degrees end in. All right, why am I doing more instruction? Why am I doing more instruction? I meant to go to my paper. So negative 340 degrees. All right, so again, drawing the XY axis, starting from the positive x-axis. Now this time going negative, so clockwise. So here's negative 90, negative 180, negative 270, and if I go all the way around, that's negative 360, which is too much. So this is negative 270. I just need to go another 70 degrees into quadrant 1. This is quadrant 1 here, and there we go. Let's say that's 70 degrees. So this is negative 340 degrees, clockwise. We're in quadrant 1. Right? It ends in quadrant 1. And again, please don't guess, right? Because the more you get wrong, the more they'll throw at you. And there's another drawing there. All right, and then which of the following images shows negative 40 degrees in standard position? So not this one. It's not starting from the positive x-axis. This one would be like a positive angle measure, right? This one's a negative angle measure, and it's negative. Negative 40 would be in quadrant 4 here. Sorry, all right, that's not going down to negative 90. It's only negative 40, and this one's starting from the positive y-axis. That's not standard position, right? It's got to start from the positive x-axis. All right, one more objective to finish. That was back to that, converting between degree and radian measure. What is the radian measure of 220 degree angle? And give your answer as an exact fraction in terms of pi. So use the number pi here. All right, and I'll show you. There's a special, when you go into the answer area, you'll see a button for pi show up. So let's go back to my paper. So I'm at 220 degrees. And I want to convert this 220 degrees amount of turning to how many radians is that amount of turning? What's the equal angle in radians? So remember, if I'm in degrees, I multiply by pi radians in the numerator divided by 180 degrees in the denominator. That way degrees will cancel. All right, so this is 220 times pi in the numerator, right? And 180 in the denominator. And there you go. But it did ask you to simplify the fraction, right? An exact fraction in terms of pi. So we can cancel the tens, right? That's 22 over 18, so the zeros can go away. 2 goes into 22 11 times. 2 goes into 18 9 times. So this is 11 times pi in the numerator divided by 9. 11 ninths times pi radians. So 220 degrees, right? This angle I just drew here is the same angle as an 11 pi over 9 radian angle, right? Rad. Right? They're the same. They mean the same amount of turning. They mean the same picture. They mean the same thing, right? The same angle. All right, so back to my calculator. Back to my assignment. So I'm going to enter, 11 pi. Now you can put like \pi. Oops, sorry. I guess that doesn't work. All right, so that was in a different software I was in. Sorry, but there should be a thing, a little calculator thing down here showing up. You see the symbol for pi show up. You just click on that, and then divided by. Let's do a forward slash or backslash. I don't know. One of the slashes, right, with a question mark button. Just do divided by, and then a 9. Right, it was 11 pi divided by 9 radians for 220 degrees. Okay. Again, you got the answer explanation there, multiplied by pi 180 like I did. Okay. And one more, negative 4 pi over 3. Now I'm going to do this one out loud here, not even write it out. You see pi over 3? Remember, pi over 3 is one of those special ones I mentioned earlier. Pi divided by 3 is 60 degrees. A pi divided by 3 radian angle is the same as a 60 degree angle. So that's 60 degrees, and then you multiply by negative 4. Negative 4 times 60 is negative 240 degrees. And notice again, I know there's a degree symbol here, but read it. Do not include the degree symbol, right? Just, it says convert the answer into degrees, so it knows you're talking about degrees there. Fantastic. And it looks like that's it for the assignment, right? And I know this one's going to be probably a bit longer because I was explaining things a lot more, like how to get to the assignment and junk like that. But I just wanted to show you, at least in this first video, you know, what these KnewtonAlta assignments look like, how they work. Now, the order that the questions I saw, the order that they came in, won't be the same order that you see them in. And they might not even be the same problems, but they are on the same material. They're on the same objectives. You would do them in the same way. All right, and everything I explained is totally valid. All right. So I hope this was informative, helps you through, and I'm going to be making a video like this for every single assignment, all right, to help kind of guide you through the course. You can think of these as my lecture videos. All right. So again, hopefully this was informative, and hopefully you get through your own assignment pretty easily. And don't forget to, before you, come to me with questions or a tutor, I would recommend reading the OpenStax book. All right, read the section in OpenStax. Take notes. Do some examples. While you're reading, practice from there. Watch the videos provided. Take notes on those as well. Practice what they're showing you. Every time you see a new objective or are struggling on a problem, click on More Instruction in the new KnewtonAlta assignment. Now, if you've done all that and you're still struggling, still having problems with still having issues with certain problems, then you can come to me, right? Take a screenshot of the problem that you're working on that you're having trouble with and send it to me, or post a picture of it in the class discussion board. Either way, and you can get help from either me or maybe even someone else in the class. But I know you can get through it, and I believe in you. Just keep working. Just keep working. And thank you for watching.